our life. And first of all, we'll introduce you about the project background.
So first is about the project background. So as you can see, according to the Vietnam News in 2023, there are 14,000 tons of garbage in the Mekong River per day. And according to UNESCO, in 2022, we have to clear up about 1.8 million kilograms of trash in the Mekong River. So with all the information, we can know that the water pollution in the Vietnam is in an alarming rate. So there's some existing solution to improve the water quality. Here's the three obvious example. So the manual cleanup effort is, cost a lot of time and it also efficient for large scale operations. About the boat and mechanized system, it limited by the river width and flow, and it also usually failing during the high level waters. The last is the charge barrier. It costs a lot of money to operate and maintain, and it also rely on the fuel and electricity. So next part will present.
I'll do the project definition and objectives. Okay, so there are three essential steps in engineering. So starting with the first one is determining the needs, creating a specification, and developing a plan. So when we're talking about determining the needs, we first need the project scopes and the objectives. So where we want to do the project and our targets on what we are going to achieve, and we have to mention the stakeholders and their needs. For the project definition, our objective is to develop a cost-effective, sustainable solution to reduce river pollution. So our innovation here is a trash collecting robot that's powered by river currents. And the impact we are hoping for is to remove plastic waste and natural pollutants and protect aquatic ecosystem. So the benefit of our system is that it improves the water quality for drinking, agricultural nutrition, and it minimizes the energy consumption using the natural river flow. And the operational costs are also marginally less expensive than the ones that are currently today in the examples shown before. Our project objective here is to generate a positive effect in diverse river and lake environments. So we are hoping that this boat can traverse in different bodies of water. We have hoping for a scalable design, so it's modular, easy to replace and maintain, as well as being cost effective. And we are hoping for a lot of funding and partnerships from those non-government organizations and those who are looking for sustainable growth. Our mission is to promote environmental stewardship and combat global water pollution. On to the project prototype specification. We first have a water navigation system. We have a waste collection system, which is used to store the waste, that is used to collect the waste up into the trash tanks, which is the trash storage system, and a safety and stability module. The feasibility here is that we use existing technologies such as sensors, AI algorithms, and motors to use the product. It's scalable production in the case that it's modular. Things are easy to replace, and they can be added upon with extra features later. It's also adaptable to different water environments, so it's not just rivers, it can also be oceans and lakes. As for business feasibility, we know that countries are now trying to promote more sustainable growth, so we're trying to push our agenda to help hopefully attract non-government organizations and public funding from those organizations and the government as well. Onto the system design, which is presented by Ben.
First we have to define the functional specifications and non-functional specifications, which was created in a report. And here's the block diagram of the design. The main system has three main parts, which is the stabilization system or the control system, the waste collection system, and the trash self-cleaning system, all which is fed inputs from sensors from the main stability sensors and the waste detection sensors. The outputs of it, the system will output real-time monitoring data from processing the inputs. So we're going to break down each of these systems. So the navigation and control system allows the machine to traverse in the water environment. The waste collection system allows the machine allows us to process what is trash and what is not trash, and allows us to pick up only trash, if that makes sense. And the trash storage system allows us to separate the trash, and will allow us to basically not only collect the trash, but maybe differentiate the trash type, and also allows to gather data from the environment. So for the design of each block, we in the processing system we have 2 lithium-ion batteries for the power supply, and which is turned on with an on-off switch. The main processing system here is an Arduino board with communications to a DC motor driver, which controls 2 motors. And then each of those motors have a propeller, and the machine is controlled through Bluetooth for wireless communications. The waste collection system features a conveyor belt to pick up the trash, and the trash load system is just a polystyrene trash, which also features as a float buoy. So the prototype design is just shown in this demo, and the reason why we decided to choose the Bluetooth module is because it features low latency and allows to control this from afar, and it's also cost effective, and most importantly, it doesn't require a password. We also decided to choose the conveyor belt instead of the flat belt system, because the flat belt system requires friction to work to pick up the items, and we decided to use a polystyrene trash tank instead of 3D printing the trash tank, because it allows us to float the machine as well. So we'll leave the next part to
Alright, so now I will mention about the testing and also the analysis of the prototype. Alright, so to sum up, we actually have this. This product, just simple, because we haven't developed the AI model yet to achieve the autonomous driving. So we will develop a control system via Bluetooth and using an app to control the boat moving to the beginning of the river, and then it will stop there and wait for the river flow to push the trash onto the conveyor belt, and the conveyor belt will move the trash into a trash tank. Right, so here's the demonstration of our product. So as you can see over there is the red pipe, is the trash that we want to collect. We want it to move into our conveyor. So now I will demonstrate to you how we will collect it. So on to the right, hold it, left, hold it, turn left, okay, so stop here. Okay, so now, as the river flow, it will push the trash into the conveyor. So, like this. over here, and let's see how the trash will move into the trash tank.
Okay. Check that out.
Use the sensors work in your system. The sensors.
Yeah, so I have also mentioned before, since we haven't had enough time
So
to.
no sensors, no.
Yes, just a very small function that to move the boat on. Right, so about the outcome, about the navigate accuracy, of course, pretty high because it requires the control of the human. So 90% for it, 10% of failures occur in areas with a high density of obstacles. Collection of efficacy 80%. The all the 20% of efficacy occur due to large waste that can't be covered, and also since it hasn't implement the AI detection model and sensor, so it's not really efficient. About the stability, it's about 95%, since you can see that our boat didn't sink, so 95% a really high accuracy of stability. Next part is the project management. So for the last step of the engineering process, we had to develop a plan. Inside the development of the plan, we had to develop the project timeline and allocate the resources and assign responsibilities to each task. Here's our task table. We took a total of 5 weeks to develop everything, and the remaining of the time we spent developing the plan and making the prototype. In reality, it took around 3.5 months. As the last month, we only wrote the report, so we did not include it here. So here's our table of the tasks we assigned to all of the members. We have we have every task and assign the different majors suitable for each task, so the skills can be implemented best and effective inside of the project. And lastly is the conclusion. So our prototype has these following advantages, which is it can innovate waste collection solution. It also can it also has an efficient design, and it is user-friendly control, and also is a scalable and versatile solution. But however, there are still some limitation to this prototype, which we want to we want some future enhancement, which we want to promote more eco-friendly materials and also efficiency in energy. We also want to monitor systems that are more smart and also improve the industrial scalability. Yeah, thank you for your attention.
So actually, I was surprised because I thought we now have in the engineering design process, and